What up? Today's Friday, September 13th, 2013. Time right now is 7:25 p.m. Very late UPS package. UPS never delivers this late, but the guy said it's common practice now. The UPS guy said that. But this is going to be an unboxing video of a used oscilloscope. I'm a subscriber of the Australian guy, Dave. I think his last name's Jones. He's the EE vlog. He has really good electronics videos. He's an electronics engineer. Well, he always talks about if you're going to get an oscilloscope, if you're not going to get one of those $400 digital ones, your best bet is to get an old analog one. So for $100, he says you can get one for $100. I think he's talking about Australian bucks. So I've been needing an oscilloscope for a while now for my projects, but I just been trying to get by. I didn't want to spend the money, and then finally I got backed into the corner on one of my projects that I need to use an oscilloscope. And after I bought this oscilloscope, I realized how easier my projects will be. Just having an oscilloscope, being able to put an oscilloscope on stuff that in the past I just used theory to try to get it to work. So anyway, I browsed eBay for like 2 weeks solid, just looking at all these oscilloscopes, put bids in them, see the best value for my buck, and I finally got this one, and let me unbox it and see if I got ripped off. I will tell you that I won this one on a bid. It had free shipping. It was from a surplus company, and it was $126. That's how much I bid it on it with free shipping. So let's see if free shipping paid off. It's actually, the box got a little damaged, but it's wrapped up, and I don't think the packaging is going to be a big problem, hopefully. Oh yeah, this one didn't come with probes. So on eBay you could buy new probes for $17, 2 new probes. This is a analog 2-channel oscilloscope. I forget the number of it, so when I open it up, that's when I'll tell you the number of it. And this seller, it was a surplus website, they had good reviews. So we'll see. Okay, came with a sales receipt. Packaging is not an issue on this one. It is definitely well packed. And there we go, after all that. So, it is a Tektronix 2213, 2213, 60 megahertz analog dual channel oscilloscope. All the switches look fine. Now, I'm going to clean up the casing, and I'm going to open it up and brush it out, clean it up. But so far so good. So now the moment of truth, I gotta plug it in. Okay, so it has an extremely long power cord, longer than I expected. So here I go, here's the moment of truth. Let me see what the power button is. Okay, it's off. Power button's off, so I plug it in. Okay, here's the moment of truth. Okay, fan is twirling. Oh no, there is no fan. Oh, hold on. No, that's just a transformer hum. And I haven't seen it, so let's do being fine. Oh, that's good. So, let me get some probes. Well, we'll leave the probes off, but let me get a probe just in case. So I'm going to have to warn you, I'm not an expert on operating oscilloscopes, but being fine. So let's see what the trigger is. triggers in auto on, we'll put it on channel 1. What is this? Source? Oh, external trigger. Oh, INT, it needs to be on INT. Okay. Norm level. I can get a good focus. Okay. Let me put a signal to it. Let's see, where's the test? Probe adjust. Oh, that sucks. AC coupling. Let's see, DC. Okay. Oh, ground. What's the probes? Okay, I'm gonna end this video right now and come back when I get it working. Okay, it's the next day. So what happened is when I turned off the camera last night, I couldn't get it to work. Couldn't get it to work at all. And I was really pissed off. I tried everything. It seemed dead as a doornail. The only thing that was working was beam find. So I packaged it back up and I sent a nasty email to the seller. Well, it wasn't too nasty. It was like, hey, it's not working. I was kind of pissed off. So this morning I'm still kind of pissed off, but I went and I decided to give it a second try. Did it, so I plugged it in. Same thing, couldn't get anything to work. I was messing around with it and I was holding down beam find and like messing with all these knobs to see if I could at least get a signal to show up holding down beam find, plugging it into this the probe adjust. And then voila, bam, it started working. So then I moved to channel 2. Channel 2 was finicky, messed around with it, bam, started working on channel 2. So then I decided to open it up, take a look at the inside, and I used a can duster and dusted it off. Very minimal dust. Whoever had the scope, as you can see, it's clean as clean can be for like a mid-80s scope. Look how clean it is. So whoever had the scope was taking care of it. But I especially dusted inside these switches here, the duster. And another thing, when I opened it up, one of these heat sinks was floating, fell off. So I wonder if that was floating around in there screwing something up. Oh yeah, so anyway, I'm gonna put it back together. Oh yeah, and I cleaned up the front. I don't know if in the video you could see how dirty these knobs were, but this scope cleaned up real good. So I'm gonna put it back together and then show you that it indeed works. Hopefully. Okay, I have it reassembled, all put back together, and let's see if me taking it apart screwed it up some more, or if it just so happened to start working and now it's not going to work anymore. The scope cleaned up nice. I mean, I'm really happy with how clean it is. Okay, so now we're back to the same problem. The triggering circuit isn't working, but I don't have anything plugged in. So let me put in the test signal, channel 1. You see, and this is what it was doing before. Now what was happening was, I got it to work by holding down beam finder. Okay, now the triggering circuit, oh, hold on. Triggering mode normal, you want it like that. Alright, this is what happened before. Oh, hold on. This is supposed to be on no delay. You see, I was flipping around these switches. Oh, hold on. Here it is. Trigger is on channel 2. Put trigger on channel 1. Put this to int. Maybe it needs to warm up. Oh, hold on. We are on the ground. We need to be on DC. Intensify. Wait, now we're getting something. Oh, there we go. We got it. See, I was messing around with the knobs. There we go. There we go. I don't know if you can see it. We got a good signal. Let me put it in focus. Okay. So this is supposed to be, according to the thing, 1 kilohertz, 500 millivolts peak to peak. So it's supposed to be half a volt peak to peak. So let me make sure this probe, okay, this probe is on 1x. Okay, so this is 0.2 volts for division, 0.1 volt per division. Okay, let's see. Oh, let me make sure all these are. Oh, that's slower. Okay, there we go. So, if I measure this out from this bottom trace, it's 1, 2, 3, 4, 5. 5 divisions, and it's at 0.1 per division. So, that's half a volt right there, peak to peak. So that's good. So it's pretty much in calibration for the volt side for what I want it to be. Now, let's see, on seconds per division, we're at 0.2 milliseconds per division. So let's see, 1, 2, 3, 4, 5, 6. So we have 6 divisions times 0.2, that's 1.2 milliseconds per division. So to find the frequency, you do 0.001, that's 1 milliseconds, and 2. And then you inverse that. I have a calculator here. So I'm getting 833 hertz. And it's supposed to be 1,000 hertz. But that is pretty close. If I wanted to know the hertz, I would have just connected my good multimeter. If I get in, oh, that's the wrong one. Let's see, if I dial in closer, will that fill up the whole screen? That pretty much fills up the whole screen, right? So now we're at 0.1 seconds per division, and we know there's 10 divisions around here. So that's 1 milliseconds. I'm probably being a little dyslexic with the way I'm speaking. And that would be 1,000 hertz. So for my use, it's in calibration. So I think this is a good eBay deal. Let's try channel 2. So we have it on channel 2. We got to flip down the trigger to channel 2. And now we don't have anything. So channel 2 was a little finicky with me before. Press the beam, fine. It's way down low. Okay, there we are. We have something. So let's zoom in. There we go. There's our sine wave. Let me put it back to okay, that's good. That's 0.1. Let me zoom out some. Move the horizontal positioning. And there we go. As you can see, both channels are working. So I think this is a good eBay purchase. So don't jump to conclusions. I'm not the best at using an oscilloscope, I'll be the first one to admit, but practice sakes perfect. I think this is a good eBay deal. So $126 plus $17 for 2 leads. I got myself a working oscilloscope that's going to do what I need. Okay, here's a good example of why I need an oscilloscope. This is a project that I'm doing that I didn't have an oscilloscope that I really needed. And I wanted to generate a sine wave. So I got the schematic off the internet to make a sine wave. But look at this sine wave. It doesn't look like a sine wave at all, does it? It's all weird. So I wouldn't have been able to know, like before I know what frequency this was by hooking in my multimeter. But I didn't know what it looked like. So now I know what the sine wave looks like and that it's all messed up. And this is at 50 kilohertz. And I went and I did a rough calculation using the oscilloscope, and my rough calculation showed me that this sine wave, and I did from these 2 points right here, since it's all weird, was 50 kilohertz. So this oscilloscope was a good deal. I'm really glad I had it. Like I said, it cleaned up nice, and it's moving all around because I had to hold the leads a special way. But you know, I cleaned it up, and looking good.